Hello and welcome back. It's time for chapter 24. In this chapter, we're going to be covering cognitive development in late adulthood, so 65 and older. All right, let's go ahead and get started. So, you're probably not going to be super surprised to hear that as we age, especially once we're getting past the age of 65, there are some changes that occur in the brain. The normal human brain shrinks up to 15% over the lifespan, the adult lifespan. So I'm going to include in the adult lifespan ages 25 to 65, the adult period that we talked about in the past section of our textbook. Across that period from 25 to 65, we're probably going to see single digit amounts of shrinkage across that period of time. From 65 to 85 or 95, as we get into really seriously older age, we're going to see more of this 15% attributable to that latter part of oldest old age. So most of the changes do occur in the very last parts of our lives. Where we can see changes predominantly is in what we call the hippocampus. We've talked about this a few times in class. This structure, it's kind of partly obscured by other structures, so that's why you're seeing some dotted lines in that drawing of the brain. You have a hippocampus on either side of your head, and this structure is really important for your current awareness of what's going on. It's really important for the transition of new information into long-term memory store. So if we see shrinkage in the hippocampus, we're going to see impacts on thinking that's occurring right now, thinking that's aware of the surroundings right now, things like that. And then also the ability to take new information from today and ultimately transfer it into long-term memory for permanent storage. So those are the primary deficits we see as a function of the shrinkage of the hippocampus. The cerebral cortex, of course, is the outer layer of the brain, and it shrinks also. And predominantly what we think gets affected would be places where you could be storing new memories, places where you could be making new associations between things. Probably on average, neurons that already have connections with other neurons that are coded as memories won't be affected by this natural shrinkage. Generally, those kinds of neurons and those kinds of synapses will be preserved, even as all sorts of things could happen to the brain, and those things would be preserved. What typically we're going to lose would be the neurons that are not being used at the moment, but that could potentially be used for something else. And so the deficits that we see will not probably be losses of memory, but maybe the losses of the ability to store new memories. That's going to be a really big effect of these changing brain structures. All right, hopefully I explained that decently enough without going into too much detail on memory and stuff like that. All right, so I don't know about you, but as soon as I hear that this is natural and it's normal, I think, what can I do to not make it happen to me? That's like the first thought I have. So what can we do, especially those of you who are younger? What could you do in, your adulthood proper that maybe could help slow the rate of brain shrinkage, so that maybe instead of having the normal 15% brain shrinkage, you've got 7.5% or maybe 5% brain shrinkage? Like, wouldn't that be better? So what could we do? Well, one of the best things that you can do to really convince your brain that you need your neurons is to continue teaching it things. So you're already taking a great step. You're in college, so that's a great first step. Continuing your education past, the emerging adulthood period is a really great idea, because the more you use your brain to acquire new information, the more your brain will continue to believe it needs to be storing new information. If you think about your brain being like any other, okay, your brain's not a muscle, but if you think about it like any of the muscles in your body, when you work out, they want to get to a point, your muscles want to get to a point where they're like, okay, I understand what this workout is. I'm adapted to this workout, and I can now just sort of coast. I don't really have to be straining myself. Your brain's sort of the same way. It wants to think that it already represents the world correctly, that it already understands the problems that it faces, that it knows these people. It wants to feel like homeostasis, right? I don't need to be continually challenged. But if you train your brain from, early in adulthood and forward that no, you will be experiencing new things. You will be learning about new concepts. You will be learning new skills. You will be taking new routes to get home and stuff like that. It's not just formal schooling, but it's other things like, changing things up. And then, of course, maintaining good health is going to be beneficial for all of our body parts, not just our brain. A lot of times when people think about exercising, they think, well, it'll be good for my heart, or it'll be good for my weight, or it'll be good for my muscle tone. But one of the things they forget about is that when we exercise, even stretching exercises or weightlifting exercises tend to get our hearts pumping harder, right? Aerobic activity for sure, but even weight-bearing activities that are not, I'm thinking of like Pilates or yoga. They tend to get your heart rate up. Lifting weights tends to get your heart rate up, even if the weights are really stretchy bands, right? It tends to get your heart rate up. And that is really good for keeping our brains healthy. Having good, healthy blood flow to the brain is really critical for keeping those neurons healthy. The worst thing that can happen to our brains is to be deprived of the oxygen that's being carried by good, healthy red blood cells. So when we talk about maintaining good health, we're talking about exercising, and especially anything that gets the heart rate up at all. And then also, of course, healthy eating, healthy diet. So including the kinds of heart healthy nuts and legumes and green leafy vegetables and the omega-3 fatty acids, like all those things that are good for our cardiovascular system are in turn going to be good for maintaining brain health. And then finally, daily mental challenge. I pulled this picture of older people playing bridge from a study that looked at the benefits of playing bridge. And bridge, I don't know about any of you, but I don't even know how to play bridge because apparently the rules are kind of complicated. There's another layer that makes it something that I don't like to do, which is that you have to play with a partner and kind of figure out what they must have without being able to talk to each other, and try and play off of each other's cards or feed them the right card. I'm talking vaguely. Those of you who play bridge might be saying I'm describing it completely wrong because I don't know how to play. I just know that it's complicated and that it has a social component to it. And so that's like the perfect balance of daily mental challenge. That the research that they conducted on older people who played bridge showed very strongly that older people playing bridge seems to really help to maintain their brain health. It has that interpersonal component, so it makes it fun. And so the researchers said, you should take up bridge. And I have not done it yet. I first have to figure out what the rules are. But like my husband loves to play spades or hearts, and I can't figure out the rules on those very well either. And so I generally lose. I have no strategy and it's no fun for me. And instead of being a person who's trying to preserve my brain and stick with it and try and get better, I just get frustrated and I don't want to play. Now that I'm telling you that story, it's making me think I should go out when I'm done with this and go invite my husband to play one of these horrible card games that I don't like and maybe try to get better, because that kind of challenge is what your brain needs to grow and develop and to tell your aging brain, no, I need all these neurons. I'm doing new things all the time. Look at me, I'm doing something else. So it's really important to have that kind of daily mental challenge. It doesn't have to be bridge. It can be anything that's new for you. And so I think I mentioned in the past that if you've been playing video games your whole life, continuing to play video games after 65 is not going to be a daily mental challenge. That's going to be something that you're really familiar with. You know where all the buttons are on the joystick or on your keyboard, and it's just not the same kind of growth opportunity that for a person who's playing video games. Adding crossword puzzles would be the kind of daily mental challenge that is on paper and pencil, right? Like you actually have to physically do it. Like that would be a different mental daily challenge. Taking a different route to get to familiar places is another great example of a daily mental challenge. Just doing a little bit so your brain is always a little off balance. That's the goal. All right. Now I'm going to spend a little bit of time talking about this. This is the last subject I want to talk about in this segment. When we talk about changes in cognition among older people, what we keep coming back to is that they're having difficulty with inhibition of response. Inhibition of response means being able to tell themselves, that's not the right response, don't do it. Keep looking, the correct response is coming, right? Like don't do the first thing that's coming to mind. being able to inhibit wrong answers, being able to inhibit wrong responses is critical to complex thinking. It's something that is a sign of maturity in an adult compared to a child. A child really can't sort through the options very well and decide what the best response is. They tend to just give the first thing that comes to mind. They don't inhibit their responses very well. So let me give you some examples of what I'm talking about. So with the inhibition of response in older age, what we start to see is that their control of those responses becomes less effective with age. So as the brain is sort of shrinking and things like that, it becomes harder to do some things that are cognitive control processes. So for example, selecting what to pay attention to. I mentioned this before when I talked about hearing declines and how oftentimes older people don't want to use hearing aids because they say there's too much background noise. Well, what they're talking about is it's so they can't figure out which part of the noise to pay attention to. Now, in a younger person who has normal hearing and things, they hear everything too. Their brains are reacting to everything too, but they only perceive or pay attention to a subset of that information. They can ignore everything else and pay attention to only those things that they want to pay attention to. So selective attention is a really important aspect of cognition because you have to decide what's important and I need to be focusing on and what's irrelevant background noise or irrelevant background visions or whatever, just what can I ignore? As we age, it becomes harder to selectively attend. And so you'll notice that older people oftentimes will crank up their TV really loud if other people are in the room talking because they can't really just ignore the talking. They can't really just ignore the sound of the fan. They can't, like, these things become like almost painful for them because it takes so much cognitive effort to try and pay attention to what they're trying to pay attention to. If you have ever been diagnosed with attention deficit disorder, you may know exactly what I'm talking about because that's your everyday life. For a lot of people who didn't have ADD when they were younger, they kind of will start to feel like they have it when they get older because they're having these control process problems. Another impact of these declining control processes is that the older person may have difficulty figuring out what the rules in this particular context are. Are we playing a new game? Like I mentioned, I'm having a lot of trouble trying to play this game my husband likes to play because I'm like, what are even the rules? Now, in my defense, I've had this problem ever since he introduced it to me like 20 years ago. So I don't think it's per se because of my aging brain. But as a person gets older, it is harder the rules seem like too many, too much. The rules of a social situation might be too much. It's harder to figure these things out with age. And then finally, we may notice in an older person that they have fewer strategies available for solving a problem. And it might be, again, their experience, right? We talked about selective optimization with compensation, and having a lot of experience with something might make us say, hey, this looks like something that I've seen before. Let's try a solution that worked in a similar situation. And that's really common for all of us across adulthood. If this current problem looks familiar, we may try a strategy that has worked in a similar situation, even though it's not the best strategy in this situation. But with age, it's possible that, more things look familiar to us because we've had more experiences. And so we think, oh, things I've used in the past are going to work, when in fact they really aren't. So our strategies for problem solving may actually honestly be impaired, or it's possible that part of the decrease in effectiveness might be attributable to the fact that they're just trying strategies that look like they should work because this current situation looks familiar. So we're not exactly sure on that. So the key thing I want you to walk away from on this section is that, it's very typical as we age that we're going to have some of these control process problems because of this inhibition of response problem that we're having. We can't really squelch very well that instinct to try a strategy that's worked in a similar situation, like you might have when you were younger. So that's a basic principle. All right, let's go ahead and stop here, and we'll come back and we'll talk in the next segment about how older people use their brains.